Welcome to the training of Maths for Data Science Professionals, and this is the first lecture which is approximately of 8 minutes, and in this first lesson we will focus on defining what exactly is data science and how a typical data science process looks like. So what we will do is in chapter 1 we will first start with a very basic definition of data science. Then we will take up a sample data and we will see a micro workflow of how actually data science works, and then we will redefine our definition with a more in-depth and professional definition. And at the end of the lesson, I have talked about two golden rules, two important rules, which will help you to focus on learning maths with data science. But the first thing is, let us go ahead and start with what exactly is data science. Data science is all about converting data to information. So you have huge amount of data which is lying in your database, you have huge amount of data which is lying in your Excel sheet or wherever, right? And you want to present that data to your management or to a decision maker in like 1 or 2 lines in a summary is what data science is all about. So you can see here at the left hand side I have huge amount of data of 100 days approximately, and this much data if I give it to my manager, he won't be able to make any kind of decision, right? So what we need to do now is we need to take all this single transaction, right? And we need to go and create a summary. We need to go and create 2-3 lines of information which can represent the summary of this data. And by looking at this information, the decision maker can make better decisions which can improve the business sales, or which can give some new dimension to the business. So that's what data science is all about. So now, for example, you can see at the left hand side, I have this number of days and per day what sales has been made. So now I can go ahead and give some summary information to my decision maker. For example, the easiest one is average. Average means on average, how much sales you are making every day, right? So I can say, okay, so here is an average, right? I can also give him some information like, okay, so what is the minimum sales you have made at any given moment of time on these number of days. So that is, I can see here it is 27, right? And what is the maximum number you have made, maximum number of sales you have made. So I can say max of this, right? We can also go ahead and use something called as the mode. Mode says that which is the repetitive number from this. For example, over here I can see that 27 is repeated a lot of times, 29 is repeated, 82 is repeated, right? So if I go here and say mode, right? So I can say mode and I can click on this and it tells me that the most repetitive sales which we make is 80, right? $80 per day. So you can see this is lot of repetitions out here, right? So it tells that the maximum number which is getting repeated in a data set. So you can see now here I have just given out 4 important summary to my decision maker, and by using this summary he can make decisions. Now what I can do is let us go ahead and not use the word average, let us use the word mean, so that all this like MMM you can remember. So mean, max, mean and max and mod, right? Mode. So I have applied 4 maths statistical formulas out here, and I have arrived to some kind of summary which I can give it to my decision maker. So now when a decision maker will look at these 4 statistics, right, he can make some decisions, or he can come to some conclusion. For example, he can see here that the average sales is 582, but at some moment of time we also made sales of 70,000. So if we are making a sales of 70,000, why on an average we are making so less per day, right? So if you scroll down below, if you see on the last day, I have made an entry of a bulk order. So must be there was some kind of a bulk order, and because of this, the max sales are looking higher and the mean is not looking proper. So must be now the decision maker can more concentrate on bulk orders so that his business can improve multifolds. Now, what has really happened in the past 4 minutes? In the past 4 minutes, if you see, we have applied data science, and while doing so, we have done 3 things. The first thing is that I have used statistical math. So I used the maths formulas to arrive to this summary values, right? So first thing is I used maths, I used statistics, right? The second thing what I did out here is I used Excel. So I used my Excel knowledge and I use these formulas like mode, the max, and so on. So because of my Excel knowledge, I was able to implement these formulas easily, right? So I had good IT knowledge of Excel, right? And the most important thing out here is domain knowledge. When I saw this 70,000 max value, my mind just went down, and I was able to figure out that this must be due to some kind of a bulk order, right? So because I had the domain knowledge of the retail or of selling, I was able to figure out, why this difference was. So in other words, I used three things actually. I used maths, I used IT. So let us not just say Excel, because tomorrow it is possible we're going to use Python, we can use R, right? So in general, I used IT, I used maths, and I used domain knowledge to arrive to this summary information. And that's what exactly is data science. Data science is a multidisciplinary field. Now let me go ahead and put forward a professional definition. So initially I started with a very layman definition, but let me put up a very professional definition. It's a multidisciplinary field which comprises of statistical maths, probability maths. It comprises of IT knowledge, where you can use an Excel formula, or you can use Python, R, whatever, right? And your domain knowledge. So that's what is data science. Now, throughout these lessons, I would advise and I would request that you follow two golden rules if you really want to get successful into the data science field. The first rule is that do not solve maths, but try to apply maths. So in other words, for example, when I wanted to calculate the average of this data out here, I did not go ahead and say x1 plus x2, till n divided by the number of n, right? I just use the average formula of Excel, right? So rather than solving maths by physical pen and paper, that won't really help you. Try to apply maths. And the second rule is that please stick to Excel and do not jump to Python and R. A lot of people, what they do is, they start with Python and R, they get into programming languages, they get into installations, but then they lose the focus of statistical maths. So I would suggest that throughout this lesson, please stick to Excel and please stick to applying maths rather than solving maths. So that brings us to the end of this session. At the end of the session, I'm giving you two Excel sheets. One Excel sheet is the Excel sheet on which I showed the demo. So you can see this Excel sheet out here, lesson1.excel. And the other Excel sheet is the practice Excel sheet. So basically, this is a practice sheet, in which I'm giving you some other data set, and I want you to go ahead and find out the mean, min, max, and mod. And I'm giving you a hint, there are two odds in this summary. So try to find out those odds. So after every lesson, I will give you a practice sheet. I will give you the sheet which I used in the tutorial. And at the end of the video, we will have a small Q&A deck which is flashed up, which you can have a look and you can summarize what you have learned in the lesson. So thank you very much. In lesson 2, we will talk about something called as descriptive analysis. So happy learning and thank you. Welcome to lesson 2. Lesson 2 covers 4 important topics. Descriptive statistics. So descriptive statistics means mean, median, mod, max, and mean. It talks about spread and the importance of spread. It talks about outlier and quartiles. Now this whole lesson is approximately of 15 to 16 minutes and it has like 4 chapters. So let us get started. The first thing a data science engineer should do when he gets any data for analysis is to identify if this data is spread or is the data concentrated. If the data is highly spread, then one value inside that data set is far away from the other value. And if it is concentrated, then data revolves around certain values. For example, you can see that we have 2 data set of sales out here. So let us go ahead and I'm going to go ahead and plot this data set. So let us go ahead and use this scatter out here. So you can see that I've used the scatter plot and I've plotted this total sales 1. Let me go ahead and create one more scatter plot which will plot the second one, right? So this one. Okay, and let me just place them side by side. Okay, I can place them side by side, or must be I can just place them down, right? First thing, let us concentrate on total sales 1. So if you look at total sales 1, let me go ahead here and just add data labels, right? So you can see in this total sales 1, when I plotted this scatter plot out here, I can see a lot of data is concentrated around certain sections. For example, let me go ahead and pull this all the data up and let us try to do a small analysis. So you can see here I'm trying to pull the data up and let us try to quickly check. So you can see here a lot of data is revolving around 80 to 88 or 80 to 90 if you wish, right? So you can see here a lot of these data sets are actually revolving around a certain value. You can see there is a other group of section as well here, like this is looks like 27 to something, so you can see again some small concentration of data here as well, right? So 27 to 35 must be, and you can see some data out here which is like almost 112, right? So this says that this total sales 1 data is highly concentrative, right? It is not dispersed, or we can say that the spread is not too much, right? Now let us look at the other data. If you look at this data out here, it is a straight line. Let me go ahead and add a data label, and let's again go and check how the data is spread, right? So you can see out here the data is having a high spread. It's going from 16 to 54 literally, and this is almost a linear graph. So definitely we won't find such kind of a pattern of high concentration, right? So this kind of data set is termed as data set which follows the measures of central tendency. And this kind of data set is a different data set which does not really have any kind of central tendency, and the way of doing analysis for such kind of data set is different. So the first thing as a data science engineer, you should find out that is your data set following the measures of central tendency, or is your data set not following the measures of central tendency. And depending on that, is your data having a high spread or a low spread, your analysis will depend, right? But now here is a problem. The problem is that if you have a lot of records, if you have millions of records, it is very difficult to plot a graph and do these things, right? We need to have some mathematical formulas which can quickly go and run and evaluate and say that is your data having a high spread or is your data having a low spread. So creating such kind of visual graphs for millions of records is almost impossible, and the whole point I showed you this graph out here is to just show you that how visually a concentrated data looks like, how visually a spread data looks like, how visually a measures of central tendency looks like, right? So let us go ahead and try to understand now that how we can go and use mathematical formulas and find out without plotting a graph, that is our data following measures of central tendency or it is not following it. So now the first thing what we need to do out here is we need to go ahead and get the description about this data. We need to get the statistical description of all this data before we go ahead and start calculating the spread measure. So for that we have the 5M formulas. The first one is the mean, then we have the median, then we have the mode. Some of them I have already done in the previous lecture, but this time I want to go more in depth. Then we have the max of the whole data set and the mean of the whole data set, right? So let me start with the first one, mean. Mean means the average. So it actually gives you a summary of your data, average, right? Median is the center of your data. So median is nothing but in a sorted data set, median value is which is coming exactly in between. For example, now let us say I have this data set out here, 10, 20, 30, 40 and 50, right? So median is 30, right? So median is nothing but the center of your data set. So let us go ahead and calculate the median. Mode I think I have already explained in the previous class. So mode actually helps you, it finds out the most repetitive value in your data set. For example, in this case it is 29, the max value, the maximum value in the data set, and the mean value. So you can see now, these 5 formulas give me the statistics description, the statistical description of my data. For example, it tells me that the average value is 581. It tells me the middle value is 80. The most repeated value in your data set is 29, and the max and the mean. Now, when I look at this data set, the first thing which catches my eye here is that the mean and median are almost like 5 to 6 times apart, right? So this is not a good sign. The mean and median should be nearby. It should be like maximum 5 to 10% of difference, right? So this is not a good sign. Now, if you see in this data set, purposely at the end, I have included a bulk value, 70,000. So because of this, the whole average is looking very bad, right? So you can see in this whole data set, there is one value out here, which is absurd, which is outside the range. So in that day there was a bulk sales by some corporation, so that's why the sales have jumped up, and because of this one single value, this whole average is looking very different. That's why only looking at the mean sometimes can be very dangerous, right? So you also have to look at the median. The median actually gives you the middle value. With that, that absurd value is not coming into the calculation, right? So the first thing what I find out here, that there is an absurd value in my data set, which is making my average looking very weird. This absurd value is termed as an outlier. An outlier is a value which is absurd and which lies outside the data set. Now in this case, I scrolled down and I saw the absurd value, but what if this was million of records, right? And you wanted to go ahead and find if there is an absurd value. So for that, we need to use something called as quartiles. So in order to find an outlier is nothing but it is an absurd value in a data set. It is a value which is lying outside the range of the maximum data set what you have, right? So so in order to go and find mathematically, right, we have to use something called as the quartiles, right? So let us go ahead and calculate quartiles, and let us see, and let us try to find out this outlier. A quartile is nothing but it divides your data set into 3 parts or 4 parts. At this moment we will divide our data into 3 parts, and for each one of these 3 parts it actually tries to find out the median. So for example, I can say this is quartile 1, right, quartile 2 and quartile 3, right? So to find a quartile, we have this formula out here, quartile, and from this data set I want to find the first quartile. So this first quartile is nothing but it has taken your data set, it has divided into 3 sections. So this first quartile is the median value of the first part of your data set which is divided, right? So then we have the second quartile. So I can say again second quartile. You can see out here this quartile 2 and the value of your median are same because this value and this value is the middle of the data set, right? So quartile is nothing but where you go and you divide your data set into sections. So it can be 3 sections or maximum 4, and then going and finding the median of those 3 halves or 4 halves. Now in order to calculate or check out the outliers, we need to go ahead and calculate something called as the interquartile. Interquartile is nothing but quartile 3 minus quartile 1, right? So interquartile is quartile 3 minus quartile 1. Now a normal range of data, the max and the mean of the data is as follows. It is the highest range of the data can go quartile 3 plus 1.5 times of the interquartile, and the lower end of data can go quartile 1 minus 1.5 into the IQR, that is interquartile, right? So in other words, now let us go ahead and find the low range. So low range is quartile 1 minus 1.5 times of interquartile, right? And the high range is quartile 3 plus 1.5 times of interquartile. So now the maximum value of a data set is 167 and the minimum value of a data set should be minus 53. So depending on the calculations, the maximum value can go to 167. So if I scroll down, I can see that this value is very high, right? So what we will do is we will go ahead and exclude this value for now, right? And by doing so now, you can see our mean and median are looking quite nearby, right? Actually, let us go ahead and put some value here, because if we exclude it again, that gets calculated in the mean, right? So I'm going to just make it 112 for now, right? So yeah, so you can see now that is 67 and that is 80. That looks reasonable, right? So by using the interquartile, we can find out the normal, minimum and maximum range of a data set, and then you can hunt down your outlier. So the first thing what you should do is, before you go and start measuring the spread, the first thing is go ahead and check out if your data is having some values which should not be included, or some wrong values, or we can say some absurd values, or values which do not go with the current data set. So try to first hunt the outlier and remove the outlier so that your calculations are genuine. So now let us go ahead and calculate the mean, median and mode and max and mean for the other data set as well, right? So let us go ahead here and start calculating the average. So there it is. I have paused the video and I did the calculations. So you can see, first thing, very interesting, the mean and median are almost equal. There is no repeating values. Now there is no repeating values in this. So first thing, if you are into this situation where the mean and the median are exactly equal and there are no repeating values, then it is very much possible that this data can be a sequence number, like a sequential value. For example, you can see here it is 5, 6, 7, 8, 9, 10, 11, 12. So that's why, you can see the mean, median and mode are looking very exact, right? Second, the max value is this and the mean value is this, right? So you can see, by using the mean, median and mode, you can find out the nature of your data set. You can find out the descriptive, you can describe your data set. For example, now I can describe that my data set is sequential. It has sequential values. When the mean and the median were very far away, I came to know that there was an outlier, right? So by using the mean and median, mean, median and mode, you can find out, what is the nature of your data set. Now let us go ahead and calculate range. Range is nothing but the max subtracted from the mean, right? So the range here is 83 and the range here is max and the mean, it is 135. Now you can see here the range of data set 1, the total sales 1, is very less than the range of the total sales 2. So this indicates that the spread of total sales 2 is much higher than total sales 1. So the first arithmetic, or I'll say the statistical formula to find out the measure is by just calculating the range. So range is nothing but the max minus the mean, right? So from this, we can know here that this total sales 2 has higher spread as compared to total sales 1. So that was this video all about. In this video, we were trying to find out, first thing, what is a spread, how to calculate spread. So first we did it visually. We used a graph and we did it. But then we said that if we have a huge data set, we cannot use a graph. We need to use calculations, right? So that's where, we went ahead and we talked about mean, median, mode, max and min. Then we also said that before we go ahead and we try to find out the spread, let us ensure that there is no outlier. So to calculate the outlier, we use something called as quartiles. We calculate quartiles, we calculate the interquartile, and then we calculate the max and the mean from the IQR, and we eliminated the outlier. And finally, we calculated the range, and by using the range, we can now know that the dataset 2 has higher spread than dataset 1. So that brings us to the end of this video. In this end of this video, I'm going to give you a small practice test, whatever I have taught in this class. So try to practice practice these formulas on those data set. And at the end of the video, we will have a small Q&A. Try to answer those questions so that you can revise. Thank you.